In this video, we'll provide solution of question number 34 of JAM Economics paper 2022. Now, we have already provided solution for this kind of question in our earlier video, but there we missed to implement this modulus while considering cos pi by 2 minus x. The solution was not wrong, but that was the solution of completely a different question. So here in this video we are providing the solution of the original question that was asked in question number 34 from the JAM Economics paper for the year 2022. Well, so let us start. The question was the following. Let f be defined by fx is equal to mod x plus mod of cos pi by 2 minus x, where x lies in the open interval minus pi by 2 to pi by 2. Then which of the following options are correct? Option number 1, f is continuous on open interval minus pi by 2 to 0, union 0 to pi by 2. Option number 2, f is differentiable at x is equal to 0. Next option is f is differentiable everywhere except x is equal to 0. And the last option is limit x tends to 0 fx is equal to 0. So as we have already seen in our earlier video that while there is a modulus in the given function, the first task is to remove the modulus and write the function accordingly. So note carefully, when you are considering mod x, this particular part will give you the value x definitely when x is bigger than or equal to 0 and minus x when x is less than 0. And for this part, note this cos pi by 2 minus x is what? It is definitely sin x. Now you are taking the modulus on cos pi by 2 minus x. So basically you are taking the modulus on sin x. So that part must be is equal to sin x when x is bigger than or equal to 0 and minus sin x when x is smaller than 0. If you are having trouble understanding this part, that why I am taking sin x while x is bigger than or equal to 0 and minus sin x while x is less than 0, then just recall the curve of sin x. How does sin x look like? Let us draw this. Suppose this is x-axis and this is y-axis. Now note carefully, how does sin x look like? If this is the origin, on the right of it, sin x will be behaving like that, and on the left of it, it will be like this. So that means what? Exactly on the right, it is going upward and it will be going up till pi. That means it is positive, it will be non-negative as long as the value of x is pi, and then it will go down below x-axis and that will be negative. Exactly the opposite thing will be happening on the left of origin. So what will be happening on the left of origin? Note carefully, on the left of origin, sin x will be negative until x is minus pi. Now note carefully, here the value of x is minus pi by 2 to pi by 2. So you do not require to consider that much. You just require to consider sin x or till pi by 2 on the right and minus pi by 2 on the left. Okay. This. So you just require to consider that much part of sin x. So definitely note carefully, when x is bigger than or equal to 0, when x is lying in this part, bigger than or equal to 0, but less than pi by 2, then definitely sin x is non-negative. So mod of sin x must be equal to sin x because it is non-negative. So that means when x is bigger than or equal to 0 but strictly less than pi by 2, same, this holds true for pi by 2 as well, but here looking on the range of x, we just need to consider it as long as x is less than pi by 2. So for x greater or equals to 0, less than pi by 2, sin x, mod of sin x is equal to sin x because it is non-negative. Similarly, when you are considering x here in this part, x is what? X is less is equals to 0 but greater than minus pi by 2, and there sin x will have non-positive value. So mod of sin x will be equal to minus sin x. Okay. So now let us combine everything. So if you are now combining everything, what will be your fx? Your fx will be now is equal to, fx will be, let me write it here, mod x means when you are considering x to be bigger than or equal to 0 and less than pi by 2, mod x will be x, and this part will be sin x. And when you are considering this range, x greater than minus pi by 2 and less equals to 0, then that will be equal to what? On the negative side it is less than x. Note that when x equal to 0, this is true as well, minus 0 is 0. So we can include equality as well. So mod x will be minus x and mod of sin x, that will be minus sin x. That's it. So that is the function we are supposed to deal with. And we have to check those 4 options. Okay. So now let us check them one by one. First of all, note one thing, that x plus sin x is continuous for x lying between 0 and pi by 2. The reason is clear. The reason is simply that x is a polynomial function and hence continuous. Sin x is very well known trigonometric continuous function. So their sum is definitely continuous. So on the between the range 0 and pi by 2, x plus sin x is definitely continuous. And similarly we can say that between the range minus pi by 2 to 0, this function is continuous due to the same reason. So first option is correct, f is continuous on open interval minus pi by 2 to 0 union 0 to pi by 2. Well, now another thing is very easy to check, and that is option number D. You just require to check whether left hand limit and right hand limit exist at the point 0 and equal to 0. So what will be the right hand limit? So if you take limit fx x tends to 0 plus, so definitely this time we'll be considering this expression. So considering that, it will be limit x tends to 0 plus fx means x plus sin x. So definitely you can, this being a continuous function, x plus sin x being a continuous function, you can directly put the value of 0 here. So putting x equal to 0, you will be getting 0 as the first term, and putting x 0 in the second term, you will be getting sin x to be 0. So ultimately you are getting 0. Similarly, if you consider the left hand limit x tends to 0 minus, that means the limit minus x minus sin x, and when you are putting the value of x 0, you will be getting 0 here as well. So definitely limit exists, left hand limit equal to right hand limit. So definitely limit of fx exists at 0 and equal to 0. So D is correct as well. Okay. So now let us check the differentiability of f at 0, whether f is differentiable at 0 or not. So we are supposed to check whether it is f has right hand derivative at 0 and whether it has left hand derivative at 0 and whether they are equal or not. So when you are considering the right hand derivative, so right hand derivative of f at 0, how will you calculate this? You will be taking the limit as h tends to 0 plus f of h minus f of 0 by h. Now limit h tends to 0 plus, h tends to 0 plus means you have to consider this value, since x is tending to 0 plus, so you must be considering this expression of fx, so that will be h plus sin h. So h plus sin h. Okay. And f0, what is f0? f0 is 0, so minus 0 by h. So that means you can see that if you put 0 in the numerator, you will be getting 0 in the denominator. By putting h equal to 0, you will be getting 0 as well. So definitely it is of the form 0 by 0, indefinite form. So for this indeterminate form, we can use L'Hopital rule here. So we'll be differentiating the numerator and denominator by differentiating the numerator, will be getting 1 plus cos h by a, and by differentiating the denominator we'll be getting 1, and by putting h to be 0 we'll be getting the value to be 1. So that is the value of right hand derivative of f at 0. Now let us calculate the left hand derivative. So left hand derivative at 0 will be calculated as limit h tends to 0 minus fh minus f0 by h, and that is limit h tends to 0 minus, what is fh? H is tending to 0 minus, so definitely we'll be using the second expression, this one, and that will be minus h minus sin h. So this will be minus h minus sin h, and f0 is 0, I'm not writing it anymore, upon h. So once again it is of the form 0 by 0. By using L'Hopital rule, we'll be differentiating the numerator and denominator. So by differentiating the numerator, we'll be getting minus 1 and minus cos x, and by differentiating the denominator, we'll be getting things to be 1. Okay. Okay, so one small mistake I have made here. This will be when you are putting h to be 0, so that part will be 1, so that will be 2. And here, when you are putting h to be 0, you will be getting the entire thing to be minus 2, so that will be minus 2. So you can see that the right hand derivative and left hand derivative are different. Right hand derivative is 2, left hand derivative is minus 2, and they are unequal. So we can see that f is not differentiable, so b is wrong. But we can see, looking into the expression of fx, that everywhere else, like everywhere else other than 0, f is differentiable, because when you are considering things on the right of 0, you are using this expression x plus sin x, and that is differentiable. And when you are considering things on the left of 0, you will be considering this expression of fx minus x minus sin x, and that is differentiable too. So f is differentiable everywhere except x equal to 0. So definitely that is true. So the correct options are A, C, and D. Thank you.